Hello student, in this video lecture we are going to see what is meant by flexibility and stiffness. Then what are the properties of flexibility and stiffness matrices. Then what is the relationship between the flexibility and stiffness matrices. First let us discuss the definitions of flexibility and stiffness. So for this let us consider a spring AB which is fixed at end A and free at an end B. The spring having a stiffness K and it is subjected to axial force at joint B. Now, because of this applied force, the joint B displaces in the direction of applied force P. So its location now shifted to B dash. So what is the displacement? So displacement between B and B dash is equal to delta. So delta, that is deflection or displacement of the spring, is equal to force applied on a spring divided by stiffness of the spring. So displacement equal to force divided by stiffness. So from that the stiffness of the spring is equal to force by deflection. This is. Then the flexibility of the spring is equal to F is equal to delta by P. So I already said the stiffness and flexibility are inversely proportional. Okay, so therefore F is equal to delta by P. So sometimes the stiffness of the spring is also called as or moment by rotation. For flexibility is equal to a rotation by moment. Okay, so let us see the definitions. As stiffness, it is defined as force required or developed to produce unit displacement. So force in the sense it includes both force and moment, and displacement in the sense it includes deflection and rotation of the joint. Okay, the deflection and rotation. So therefore the stiffness, so what is meant by stiffness of the spring? It is defined as the force required or developed to produce unit displacement. Then what is meant by flexibility? So it is defined as a displacement produced by a unit force. Displacement produced by a unit force. So again the force in the sense it includes for both force and moment. Displacement means translation and rotation, that is deflection and rotations. Then now see the properties of flexibility and stiffness matrices. First one, so these are very important. Okay, first one, the flexibility and stiffness matrix are always square matrix. So when will you say a matrix is a square matrix? So square matrix means the number of rows and number of columns are equal. Okay, so it may be 2 by 2 or 3 by 2, sorry 3 by 3, 2 by 2, 3 by 3, 4 by 4 kind of things. Number of rows and number of columns are equal. Then second property, the diagonal element will be always positive, other elements can be 0 or negative. So it is very important property. The diagonal elements, that is A11, that is A11, A22, A33 and A and so on, up to ANN. So it is called as a diagonal element. This element will be always positive. All other members, that is A1, A21, A31, AN1, these. So these are the elements. Either it may be 0, positive or negative, whatever it may be. Then third, the matrix will be always symmetrical about the diagonal. it means the transpose of matrix will be unchanged. It is because of applicability of Maxwell's reciprocal theorem. So the flexibility and stiffness matrix are always a symmetrical one. So therefore the transpose of a matrix, flexibility or stiffness matrix, is same as the original matrix. Okay, why it is? Because means it is it is because of the applicability of Maxwell's reciprocal theorem, that is Fij is equal to Fji for, or F12 is equal to F21. For stiffness matrix, Kij is equal to Kji, K12 is equal to K21. Then number 4 property. The order of the matrix is the number of coordinates chosen for solution of problem. Okay, so the order of the matrix, it is a square matrix, so order of the matrix is equal to number of coordinates chosen. So in case of flexibility matrix, it is equal to a number of redundants. For stiffness matrix, it is equal to a degree of freedom. Then fifth point, property, the element of flexibility matrix or displacement. We already know the flexibility F is equal to deflection divided by unit force. P is equal to 1. Unit force means P equal to. So that is deflection produced by a unit force is called as flexibility. So therefore the elements of the flexibility matrix are always a displacement. Then sixth property, element of stiffness matrix are always forces. So from the definition of stiffness, K is equal to a force by deflection. That means the force required to produce unit displacement. So displacement is equal to 1 means a stiffness is equal to force. So therefore the element of the stiffness matrix are always forces. Now let us see the relationship between the flexibility and stiffness matrices. So from the definition of flexibility, we already know F flexibility is equal to deflection divided by force. So from that deflection or displacement delta is equal to F into P. So it may be represented in a matrix form. So therefore delta matrix is equal to F matrix into P matrix. So let us take this as equation 1. Then from the definition of stiffness, K is equal to P by delta. So from that P is equal to K into delta. Then again it can also represent as a matrix form. So therefore P matrix is equal to K matrix into delta matrix. So take this as equation 2. Substitute this equation 2 in equation 1. So therefore a delta matrix is equal to F matrix K matrix into delta matrix. So in order to prove, so delta is equal to delta, when it becomes this delta in the left side is equal to delta in the right side. So this is the only case if the flexibility matrix and the stiffness matrix is equal to unitary matrix. Then unitary matrix multiplied by displacement matrix, which gives again displacement matrix. Therefore both the side will be same. So from the relation, from this we found that the flexibility and the stiffness matrix is equal to unitary or identity matrix. So therefore the flexibility and stiffness matrices for the system are inverse of each other. So flexibility matrix is equal to inverse of stiffness matrix, or stiffness matrix is equal to inverse of flexibility matrix. Thank you.